So if number of bad hair days tends to average 0.5, standard deviation from person to person, if you take a bunch of them, you get 1.4 for the standard deviation. Okay, if we have 400 people report the number each month for a year, then the average of those monthly reportings won't be exactly 5. You'll get 12 different averages, and those averages should have a standard deviation of about 0.07, the 1.4 divided by the square root of 400. Pause for a minute, got some noise coming up the hole. So our month-to-month averages for n equals 400, for 400 people reporting according to these conditions, it's going to be distributed like this, with a mean of 5 and a standard deviation of 0.07. At least this is what we expect. Now, big point here related to confidence intervals. Here's z equals 0, z equals 1, z equals 2. Z equals -1, z equals -2. Okay, z equals 1.96 is here, okay, pretty close to 5.14, probably still rounds off to 5.14, and z equals -1.96 occurs here. And as we've seen, you got 2.5% of the area to the right, 2.5% of the area to the left, and in between we have the remaining 95% of the area. Now this is translated as 95% of the time you're going to expect this reported mean to be between here and here. And that's your 95% confidence interval for where that mean should be. So I've written it that way. I've written 95% confidence interval. And some of this might be just a little bit off the screen, but I think you understand what I've been saying. Okay, so here's your 95% confidence interval between 4.86, or just a little less, and 5.14.